All right, so here's an example. So solve an initial value problem. It says solve the initial value problem. So we're given this derivative here, and then we're given an initial value for the original function, right? So so basically what we're trying to find is we're trying to find y, right? Y of x. We're trying to find the y function. And so first we want to find the antiderivative of this, right? And so y would have to equal the antiderivative of sine of x, which would be negative cosine of x, correct? All right, because the derivative of cosine would be negative sine. So if we had a negative sign, that would equal positive sine. And so then we just add our constant, right? And so now we know when y equals 0, or excuse me, when x equals 0, y equals 5, right? The output equals 5. So this is actually a situation when we know when x equals 0, that's actually the y-intercept, right? And so a lot of times that will give you c explicitly, but let's see if that works here. That doesn't always work. It works with polynomials where if they give you y of 0, that's actually what c equals. But in this case, let's plug that in. So let's put a 5 here as our output, okay? And then we'll put 0 here as our input. Okay, that's what this says, right? 5 is the output and 0 is the input. All right, then we'll solve for c. Now, cosine of 0 is actually 1. If you look on your trig table or a unit circle, cosine equals 1. So what we have here is we have 5 minus 1 plus c. Oops, 5 equals negative 1 plus c, I should say. All right, so then we're going to add 1 to both sides, and we'll get 6 equals c. All right, so then when we rewrite this, we want to find what y equals, right? So we're going to write y equals negative cosine x plus 6. All right, so it's actually, once we find this c, we're not done yet, right? Because we're really trying to find the equation, the value of the original function. And so we want to rewrite the function as our final answer, okay, with that constant included. All right, so let's try this one together. So here we have another initial value problem. We have a different function here, 3x to the negative second power, and then they give us these initial conditions, right? When our input is 1, our output is 2. All right, so first of all, let's find the antiderivative of 3x to the negative second. So go ahead and do that. All right, so if you got negative 3x to the negative 1 plus c, good job. All right, and you could also write it as negative 3 over x, right, plus c. That works too. All right, so now let's plug in our initial conditions, and let's solve for c, okay? So go ahead and plug in 1 for x, right? That's our x value. And then go ahead and plug in 2 for y, our output value. And go ahead and solve for c, okay? All right, if you got c equals 5, good job. And finally, go ahead and write out our final answer, which is our final equation, y in terms of x, okay, with our value, our constant input. All right, so if you got y equals negative 3x to the negative first plus 5, good job. You can also write it as y equals negative 3 over x plus 5. That works too. I chose to keep it in the kind of the format that they had here with negative exponents as opposed to, you know, as a rational expression there. But either way works. Okay. All right, so good job. Now you know how to do initial value problems. So next we're going to apply it to a real life situation.